Xiangqian, are you talking? You're on mute. Hello? Can anyone hear me? Oh.
Yeah.
Can't hear you fine, Xing,
Yeah.
but I can't hear Xiangqian.
Oh, looks like he has some problem with his mic. Okay.
Okay, now that's the problem. If I share my screen, I cannot say anything.
Oh, okay. Let me.
That's awesome.
Let me share. Okay. Just
It
let me share.
automatically blocked me from saying anything. I hope this doesn't happen to Sean later on, because he has to probably also share his screen.
Okay. So let me actually share first. Let's see. Okay.
Okay, I was completely talking to myself then. Okay, okay. I get started again. Today is December 1st, 2021. This is the data protection working group meeting, and this meeting will be recorded. Today we have two main agendas. The first one is we welcome Sean to give us a talk to give us a discussion over the DR topic in Kubernetes context. And then there's an open issue in the snapshot controller. Xin, I believe you put it over there, right? We can quickly go through.
I think someone else added that. I don't know who added that, but we can talk about that.
Yeah, we can quickly go through the bug over there. With that, Xin, I think we need to give Sean the presenter or host.
Oh, yeah. Sorry, hold on. Let me actually make you a co-host.
Yeah.
Okay, can you try? Can you try to?
I'm gonna do that.
Oh, let me add. I need to stop sharing first. All right, try that.
Yeah. Can you folks hear me?
Yeah.
Yes.
Okay.
It's weird.
And you can see the presentation, I'm going to assume.
Yes.
Yeah.
All right. Thank you. So let's get into this mode. Hi everybody. My name's Sham. I have Madhu with me, who's I think in the call. We work at Red Hat. We work on Kubernetes and OpenShift and stuff, and also with Ceph. We had a brief introduction to the disaster recovery topic using storage-assisted volume replication about a month back now, maybe 3 weeks back. This is a follow-up to that to try and present what we've done and take the discussion forward. So with that, the biggest disclaimer is this is just presented as to serve as a discussion. This is not presented as a solution that we should go ahead with and do and things like that. So we're going to split it into 3 parts. The first part's the problem, which kind of revisits what we already talked about and what we understand as commonality across storage systems in the volume replication space, both synchronous and asynchronous, and present a sketch of the solution that we are developing, presented at KubeCon, so that we can then make it something cross storage, which is the whole desire of talking to the working group. Let's go ahead. So I'll run through this a little quick because most of this is understood or already discussed, but please do interrupt. Like I said, this is to serve as a discussion. So do interrupt if there are questions or comments and so on. So why volume replication? The intention is primarily for disaster recovery use cases. The idea being replicate volumes to an alternate storage cluster and leverage the replicated copy for recovery purposes. Attach the workload to the replicated copy and continue functioning in case of disaster. And overall, it helps reduce the RTO, RPO times for the solution as the replication is handled at the storage layer and so on. And it's ready to use on the alternate storage cluster, pretty much. It's not in a backup or an object store that needs to be pulled back to recreate the storage endpoint and hence the workload. Technically, this is also extensible to just relocate workloads across these clusters, but these would be limited to storage solutions, homogeneous storage solutions, because storage replication typically works across homogeneous storage clusters, not heterogeneous clusters, which basically means different vendors and so on. From a disaster recovery point, from the cube, this still leaves out the application resources. This discussion, we do have some thoughts on that, but more later on that. It does leave out the application resources like the pod, secrets, config maps, whatnot. It kind of leaves out that you actually need an alternate Kubernetes cluster, which needs to be ready or created so that the workload can be moved to an alternate topology segment from a recovery perspective. So again, quickly, how's data replicated? What's storage-based data replication? We do have a slew of tools with backup, but like I said, yes, they can be leveraged. But the intention here is to leverage storage vendor-supported volume replication features, for example, like RBD mirroring in SES and Snap Mirror in NetApp and various other such technologies that exist. Primarily because it helps. There are various reasons why storage vendors provide this. There are probably in this group, we can add 10 more bullets as to why this is being done. But in general, it offloads replication to the storage system. Delta transfer efficiencies are inbuilt into storage systems based on change blocks or snapshots and journals, whatnot. It's basically a feature of the storage system, how they optimize their transfers. And also, it's historically readily available feature by some storage vendors. So how to make it cloud native, how to leverage that in Cube and provide it to users. That's the point here. Storage systems also support synchronous replication within latency tolerations across storage clusters, or depending on how their solution looks. So that is also a desire in terms of addressing the same. With that, let's take a quick look at what does the system look like. We are really talking about using a replicated copy in a totally different Kubernetes cluster. The DR use case is to basically recover the loss of a kube cluster and possibly the loss of a storage cluster in a given topology segment, region, or a zone. And hence the replicated volumes are not intended typically to be reused in the same storage cluster. In the same Kubernetes or storage cluster. And in general, to retain low RTO and better utilization of resources on both topology segments or n topology segments where the data is being replicated, there are 2 or more Kubernetes clusters with volumes being provisioned on a local storage system, and the storage system are peered for replication. And some or all volumes are paired for replication, right? So all volumes are not necessarily replicated, only some are replicated based on which volumes are chosen for replication. So shamelessly pulling out a slide from the talk, it basically looks like so, right? I mean, there is an East Cube cluster and a West Cube cluster, and there are 2 storage systems, East and West, which has replication peering established and based on whatever the storage vendor needs, which is out of the scope of this talk or what we even want to do with this. And local PVs are provisioned with the local storage system, and they're replicated to the remote system. And the intention is to kind of see how we can recover this workload on the West cluster and how we can also manage this replication relationship using Kubernetes. Which basically brings us to the gaps that we have in this area, is that we do not have any APIs to manage the replication desire or state per PVC and later per volume group when we have volume groups in play. And the desire really is to enable users to manage replication for their volumes and not a system administrator or a cluster administrator dealing with this. We'll touch on that a little later because that defines how we want to define the APIs when we get there. The other gaps or problem area is that the application workloads, they come with their PVC definitions. So if you just reapply the application to an alternate cluster, dynamic provisioning will kick in and deploy a new volume, whereas we really wanted to attach the PVC to a replicated copy of the data, not not get into dynamic provisioning. So that's another gap. But of course, this has certain solutions with the data source and other such enhancements that are already provided, but which can be leveraged. But it's a gap nonetheless. Other notable gaps which we're not dealing with again in the discussion today is it would be good to actually have application quest replication as well, just like application quest snapshots. But this would be no different than the application quest snapshots. But once that is in play, I think this will automatically enable application quest replication as well. And also beyond the 2 Kubernetes or clusters that we're talking about, external traffic also has to be rerouted to the appropriate kube cluster on a disaster and recovery, which is again something that we're not talking about in this scope. All right. With that, moving on to our understanding of how different storage, what's common across storage systems that provide such replication, and hence probably provide a stepping stone to design an API or set out the needs for such an API. Again, disclaimers is landscapes wide. There are many storage vendors, so what we talk here is probably not going to cover everybody. We hope to at least covers most, but we also want to be educated on what we're missing so that we can design this better. It also will. We also not interested in how storage systems are peered for replication. We are only interested in how volumes created on such systems are managed for replication, because again, various storage vendors have different ways of peering clusters. I don't think we're trying to standardize on that or provide an API or abstraction for that. With that, one of the first actions that usually happens across storage systems are that different volumes are paired for replications. This goes with pre-created volumes are paired for replication, or a pair is dynamically created on a peer when replication is enabled on a local volume, which basically assumes that there's some level of control plane communication across the storage systems. These are the two formats of pairing volumes that we've come across predominantly. And also, this is more an implementation detail, but something to remember as we discuss later. These volumes may be similarly named or different. So so initially, one of the operations that happens is pairing or enabling replication on a volume. Also, some commonality that we notice across systems is that the volumes individually are assigned roles, primarily something called a primary and a secondary or multiple secondaries, with the primary being the active source for writes and IO and is the source of replication. It's replicated to the secondaries, and which is the target for the replication. And replication can be two-way or n-way, but with only one volume designated as the primary. If it's not an active scenario, that the volume is being used in two sites.
Hey, Xiangqian,
Yep.
do you want us to hold questions till the end or interrupt you?
No, please interrupt me.
Okay. Just with regard to how storage systems are paired and how volumes are paired, having worked on various types of cross-platform replication APIs in the past, but my observation is that the one thing that you can't hide that does tend to bleed through and cause problems with regard to pairing is when the failover granularity is not at the per volume level. There are lots of designs that involve setting up a pairing of like a pool to another pool, and then every volume in the pool is replicated to some other pool. So like you can pretend that the volumes are being replicated individually, but like if you can't fail them over or break them on a volume by volume basis because the replication is happening at some coarser granularity, then you have problems that are unavoidably bleed through into the API or the user interface. And that's usually one of the big sticking points, is that there's some storage systems that literally do it on a per volume basis and you have fine-grained control, and other ones that insist on pretending to have individual volume pairings, but in fact it's done at some coarser granularity, and you can't fail over one volume without failing over all of the volumes.
Got
and-
it. Can I, so one of the things I think we understand why we need volume groups. So when we get volume groups and sort of go back to, I forget where, here, sort of go back to, instead represent the replication relationship at a volume group granularity rather than at a volume granularity. Does that help?
Yeah, I mean, you got to be careful though to have different types of volume groups. Like there's volume groups for the purposes of replication. There's volume groups for the purposes of consistency. There's volume groups for the purposes of asset management. I mean, there's all kinds of different ways to slice and dice your volumes. And I would just be careful about assuming that every volume group is a unit of replication. But yes, you could have a type of volume group which was specifically for replication and design your APIs around it and get things to work. It's just more complicated then, because you probably have to do both that and something for the individual volumes that are not grouped. And then you have to have a way of communicating to the user, like sometimes you have to use groups and sometimes you don't have to use groups, and it's a detail of the implementation. And it makes everything more complicated and ugly. It's not insurmountable, but it's makes your job harder.
Yeah.
So Ben,
Actually,
Ben,
I think volume groups would complicate things. Mainly going back to your comment, Ben, the first comment, that a lot of storage systems, they do replication, or at least they establish a peering relationship, let's say at the storage server level or storage virtual machine level. And if volume groups span different storage backends or storage endpoints or peering endpoints, it gets even uglier.
so Ben, Sazala here. Hey, so nice to meet everybody here. So one question is, like, in the recent, I guess in the last decade, VMware has this vVols. All enterprise storage systems have kind of adopted vVols to some degree or the other. So I'm wondering if vVols kind of forced everybody to kind of actually have this per volume replication topology. I do agree that open source like storage software probably doesn't have those features, but I'm wondering if enterprise software has these features.
I mean, speaking for NetApp, I'm sure that some of our implementations of like Kubernetes volumes could do this, for all the reasons you mentioned. Like, of course, we support vVols and all the VMware stuff, but then we have other ones that either don't or they work differently. And if people are going to say, well, I want those to also support volume replication, then we're going to be saying, well, it's going to work differently. That particular flavor of a volume is part of a pool that can only replicate at the pool granularity, and so we can't give you the kind of semantics you would normally get. And it just becomes very complicated where some implementations can do some things and others can't, and there's no easy way for the user to know upfront what they're going to get.
But when the application use those pools, they will still be consume each PVC, right? You would still need to have like some type of volume handle.
Right. But the issue then becomes like if the expectation on the user side is they can take an individual PVC and break the relationship or fail it over somehow, and in reality they can't because it's part of a group that has to be failed over as a group, then the user's expectations are violated. And again, it's just very hard to set up a system where people know what they're going to get, and where it works the same across different implementations. Because if you have one of these implementations that does replication at some other granularity, you just can't do the same set of things.
So like Ben, I guess you're talking about maybe SnapMirror, which kind of probably replicates aggregate or something.
I mean, yeah, NetApp has SnapMirror that replicates individual volumes, but like our Trident CSI implementation has a mode where you put multiple volumes in the same flex file. And so in that situation, we can't mirror the individual volumes. You can only mirror the whole flex file, which is the de facto pool of volumes. And so we could just say, well, we don't support replication in that case. And maybe that's good enough, but I'm sure there will be other cases where someone will say, no, I do support replication, but it has to be at some group level. And then you have complexity. And
so I guess the question for this group here is that should we force a design where we force all the storage vendors to adapt to this API, or do you want to actually, are you suggesting that it should accommodate everybody, is what you're suggesting, Ben. Is that correct?
No, I'm saying if you tried to accommodate everyone, you're going to end up with a really complicated and messy API. And
we can have capabilities, right? So that's what CSI has. We have a lot of capabilities. There's really just maybe one or two things that are really required for every driver, right? Only the mount, unmount. Everything else is optional, including create volume is optional. So those are all controlled by capabilities. So we can do the same thing here. Maybe individual level replication is one capability, and then group level replication is a different capability. So we could.
Xing, I think what Ben is saying is that if you do try to solve for everybody, it'll become complicated and kind of takes too long. Maybe it's best to have an opinion and then say, okay, this is what it is, and go with it. Like what Sham is proposing.
I don't want to discourage any particular approach. I'm just saying that, like, having tried to do it in a way that pleases everyone, you end up with an unavoidably complicated user interface because, you know, you can't set the expectations properly up front on what will work and what won't work.
Yeah, fair enough. I think it reminds me of this, long ago, there's an API called OST from NetBackup called Open Storage Technology, whatever. And then opinion, and they kind of like try to do this, and people slowly adopted to that technology.
Tom, Dell, agree with Ben. Main reason to have the groups is for consistent failover at a single point in time of a group of volumes.
Yeah, I can. I think I get it in the sense, you know, I think group support is needed. I do not deny that. The question or observation seems to be, if something's part of a group, can you break out of it? Can you break into it? Should we provide that flexibility? Should we complicate it, or just set user expectations? You get a group or you get PVC. And I guess that's a fair thing to look at. And if you go around solving it for everyone, because the space gets a little messy because a lot of people do things differently, but if you distill it, it kind of comes down to certain core patterns.
Sham, other question I have is, when you have a group of volumes you want to replicate, let's say individually also, if they're not consistently kind of snapshotted together atomically, then there's a problem with DR because, for example, Cassandra has like, let's say 10 different volumes. If they replicate individually, that's not going to help. You need to kind of make them all atomically snapshot and send the data. Is there some thought on that? Maybe you have more slides. Maybe I can wait.
No, absolutely. I'll just tell you this. This is why I just put it later per volume group here. My intention or thought was that replication is per PVC or per volume group. These are the two. PVC is not a grouping, but these are the two levels of abstraction that we have. We have PVCs. We're getting to volume groups. Because even now snapshots are not the same Cassandra example, right? And the snapshots are not going to be consistent across these Cassandra volumes because we don't have a group that we can snapshot against. And I know Jing's working on the proposal for the volume groups. My answer is yes, we absolutely need groups. I was literally thinking when we have volume groups, we extend / use that as a replication boundary. And we do need application quest replication as well, so that it's actually consistent as per the application, because otherwise we just continue with the crash consistency that we have. They are requirements.
So I have a quick question here. I want to take a step back. When will the replication relationship be broken? I mean, in the DR case, your original cluster is completely gone. Where the API operations, like deleting the, let's say we will expose some API over there's called relationship, whatever it is. The cluster is gone already. And we cannot expect with the gone of the cluster within the DR case, the controller will do the appropriate things to break the association between the source volumes and the destination volumes.
Mm-hmm.
How do you envision this be handled in the Kubernetes world?
Okay, so let me. I'll come back to your question. I think, and I have an answer.
Got it.
But that I'll come back to your question.
Cool, thanks.
All right, so we're talking about pairing and grouping and so on. let's continue on roles, which we talked about primary and multiple secondaries. And this probably answers the next question. So the other operation there are two other operations that are supported, right? I mean, there's failover and failback. And failover is typically when the server is down, where a chosen secondary volume, if you're just talking about two-way replication, the second volume is forced to become a primary, which has to happen at the secondary, at the peer storage cluster. So the Kubernetes cluster that actually would talk to the peer storage cluster is where this forced promotion would actually have to happen, which probably answers the question that you were asking.
Yeah,
Yeah.
I don't know. I don't know whether this will.
Yeah. So basically, I would say we need some fencing API to force like the disconnection and force, but or it's up to the storage system, because, for example, our storage system, when we force promote, handles it. Make sure that even if the first cluster is still running, it cannot actually access write to the PV. So it's either by the storage system, or we need to think about API that in Kubernetes somehow against that PV and make sure that even if the first cluster is still running, the data is not written or basically not corrupted.
Okay, if I understand you correctly, there's some kind of flag is expected from the storage system telling you whether a pair volume is currently a primary or secondary. Is my understanding correct?
Yeah, yes.
Yeah, it can force a secondary to become a primary and make sure that if the old primary is running, it still won't be able to write the data. And that's one option. Most, I think, storage systems do that. And if not, then we may extend the API to do some fencing, actually tell the first cluster you cannot write, like in the Kubernetes level, to make sure the PV is not accessed within.
So although I said the action of forcing it to a primary has to happen on the secondary cluster or on the peer cluster, and fencing is something, I mean, there are two forms of replication here, right? I mean, there are synchronous cases and there are asynchronous cases. The synchronous cases definitely needs, not definitely, at least in my experience for storage systems, needs fencing. You don't want to corrupt the data because there could be a spurious node which is still alive in the primary cluster accessing the sync point. So you need to very clearly break the relationship and or define the replica relationship before starting to use it. But that has to happen on the surviving end, not on the, so you won't, yes, you will not have the control plane that failed, and it has to be done on the control plane that survives.
Got it. The interesting thing is that it's really hard to tell without human or manual intervention, because if it's just unreachable, it is possible there's a temporary like network issues, whatever, in the primary storage system where the associated stuff is not there. And after 5 minutes, it came back. Then what will happen? The original association is still there in the original cluster, right?
Right, but if you break it on the secondary, it would block any additional. So it would basically, once they come back in sync, they would tell it, the surviving one would tell the original one, hey, I cut you off, we've diverged now, and I'm the new primary, and you have to discard all your old data or something like that.
That is
Yes.
based off of the storage system has the capability of doing that, right?
Yeah.
Well, I mean, that kind of functionality is necessary for any kind of a resync or reestablishment of a broken relationship. You need to decide who wins and have the loser sort of sync up with the winner, right?
All right. Okay.
So,
Go ahead, please.
sorry, so that's what I referred in the second bullet. So typically recovery, what happens is when the storage system on the failed site is back up again, the contents have to be, I mean, it has to be, now it has to be marked as a receiver, which from a role perspective, we discussed primary, secondary, so it has to shift to a secondary role. And the storage system would resync the data to the secondary, understanding that there is a new primary in play, which is what typically happens.
Yeah, and
But
another
this is
comment.
vendor operations here, but if you distill the vendor operation, there may be 3 steps to do this, 4 steps to do this, 2 steps to do this. But if you distill the operations, it's pretty much, if I assume if a volume's marked for a different role, like secondary, it starts resyncing from the known primary. And if the known primary is divergent because it was force promoted, it probably does a resync and from the last non good snapshot or however the storage system implements it, which is what Ben was also alluding to, if I'm not wrong.
Yeah, and another comment, when we decide a cluster is down, it's not by the storage layer. It should be decided much in the upper layers. And it could be a human that decide that your primary site is down. It could be some automatic so some software detection, but it will be in a higher levels. It won't be in the storage. The storage system doesn't really decide it. From my perspective, you should get like in basically a state change. There was a failure, please failover. It's not something that detected by the storage and he decide this PV now needs to be primary. He gets an event that there was a failure and he will start failover.
Also, the storage, I mean, this is probably getting into the details, but the storage system could also report unavailability. The kube cluster could still be available, but the storage cluster has issues for whatever reasons. And that could be another disaster scenario that requires failover. But the monitoring is at a much higher level than only storage.
Right. There's no reason not to report what information you have, but you would want the decision making to always come down from the top, not to come up from the bottom.
Yes.
Yes, exactly.
Also, Sham, the most common thing people do is not failover. They do DR testing, which is kind of not breaking the replication, but just trying to see if the other side works. And they do kind of set up a test bubble and try to run their workloads on the other side to see if it's all coming up. We may have covered this in a different slide, but just want to share that.
No, that's perfect. Actually, I have not covered it in the slides, but yes, DR testing is something that is required without loss of data, which no, I'm not covered in the slides, but yes, we are also thinking about that, but trying to figure out what to do in that case. All right. Sorry. Moving on.
I think one thing you didn't capture on your slide was if the secondary endpoint has a different IP address or different, ID than the primary, it would be a disruptive, failover, and how that's taken care of at the Kubernetes level.
If I understood you right, it basically, if the alternate Kubernetes cluster has a completely different IP range, let's assume, and so the application, when it's going to run on that alternate kube cluster, will.
No, I'm not talking about I'm talking about the storage servers. So let's say you have a storage server.
I thought we were talking about a scenario where like the whole site, the Kubernetes cluster and its storage are all gone. So you're going to a new Kubernetes cluster with new storage that has replicated copies of your volumes, but they're different volumes, right? So it's not the same PV. It's a different PV in a different cluster with the correct information for the replica.
Right. So basically, all the PVs have to be new and fresh on the destination cluster, on the secondary cluster.
They could already exist before the failover and just not using them yet in principle, or you could create them just in time.
Yeah.
But in terms of the network connectivity, I think that was being alluded to. I believe, Sham, you mentioned earlier that that is not being dealt with, right? That's outside the scope of getting the clients from east to west. I mean,
yeah, that was that's why I refer to that point. That was about external clients to applications running the kube cluster. But the question was clarified, stating it's about connectivity to the storage system, not external connectivity to the applications. Am I right?
I'm talking about applications that are running within the same Kubernetes cluster, let's ask in cluster A. So it's not necessarily external to the Kubernetes cluster. If it's external to the Kubernetes cluster, then you need something like a, global load balancers to make it seamless, which is not always possible, right? But even the easiest, simplest case scenario where applications are running the same cluster, let's say on cluster east, and now if you're doing failover to cluster west, now you're spinning up a whole bunch of new pods, PVCs and PVs, and that kind of goes back, whether these PVs are creating advanced or not. Obviously, you cannot run pods in standby because unless you have a fencing mechanism that would prevent IO to the secondary copies, you're going to have problems. So, I imagine like the pods get instantiated once you do the failover. You're not running them in standby.
Yes. Yes. The pods are actually transferred over once the failover is complete. That's correct. And I would assume services within the Kubernetes cluster will have to auto adjust to the new service endpoints. So the IP address for services and our endpoints for services does not really matter, but I could be assuming something.
Services don't matter because that's between just Kubernetes pods. Here we're talking about storage access, right? So as long as it's but the services are, unless you expose storage as a service in Kubernetes, which I guess for software-defined storage is possible. But again, that should be okay, as long as PVCs and PVs, look, the STS instance on the destination cluster can work with the new PVCs and PVs.
Yes.
Like, do you have a working prototype? Look, or this is more like a just thinking about. Look, I just want to look, for example, like, do you have an implementation or prototype based on Ceph or something else, or?
Yes, we do. So let's go down a few more slides. Okay, so I think we understand failover. We talked about recovery a bit. There are going to be use cases where the entire cluster is gone and the peering relationship has to be reestablished. And then there is the failback, or get it back to the original cluster, where it involves more coordination. I mean, you need to mark the current primary, secondary, and then move it back to the alternate cluster. So let's quickly jump in here. There are some caveats to the working prototype that we have. Let's call it that. It does assume 2 or n-way replication, and what I mean is that you can actually flip roles and the replication direction would change. It does not deal with pairing pre-created volumes or pairing post-creating a volume on the target. It deals with the storage system capable of creating its pair when it's replication enabled on the local instance. And the unfortunate last part of it is it assumes that the CSI volume handle is reusable across the peer storage systems, which is probably not a very good assumption, but that's what it assumes. With that, what we have, again, just borrowed the slides, there's a lot of content here, but what we want to do is we want to have a volume replication resource which would point to a persistent volume claim and set a replication state, as simple as that. And so a PVC, so user deploys the pod, deploys the PVC, and creates a volume replication resource for pointing to the PVC. The storage systems are already replication peered, so this particular image goes down to the CSI drivers and then reaches the storage control plane. to start the replication process, and also designate the volume as primary on the east, right? We also extended this with a volume replication class. This helps us carry secrets. This helps us carry vendor-specific parameters. Helps us carry replication schedules. Instead of giving the user the flexibility of saying replicate every minute, every 3 minutes, or if it's asynchronous replication. It's primarily focused on asynchronous replication initially. Now coming to the more interesting parts is when east goes down, the process of recovery is to basically, you recreate the PVC, point the volume replication back to the PVC, and set it as primary. East is still primary, but that's fine. So when east recovers, somebody will come back and change the volume replication on east to primary to secondary for the resync to start. The biggest problem here is that what is created first, because volume replication points to the PVC, and it would hence refer to the PV and send a request to CSI. Whereas when you recover, if you're going to create the PVC first, dynamic provisioning is going to take over, which is where what we actually do is we back up and restore the PVs first. But this is unfortunate because this is not user controlled any longer, because the user cannot take a PV and back it up and restore it onto a different system. So we are thinking of using data source as an alternate to this whole thing. We'll come to that later. But assuming you allow PV copies for the moment, you copy the PV, you recreate the PVC, so it will bind back to the same PV. You create a volume replication pointing to the PVC and flip its role to primary or secondary, however you want to manage it. And then you deploy the pods. The ordering would be that way.
Hey, Shyam, I have a question. Mm-hmm. So in the bottom, there's a line, application management. Is that data traffic or is it just control traffic? And then there is a line with number 3, which is volume replication. Is that how the data, so how is the data flowing, replication data?
Okay, so the replication management link between east and west is both the control and data plane of the storage systems. The dotted lines 1, 2, and 3 are simply objects that are being restored onto the west cluster. Data is not flowing through the kube clusters. That's just the whole point.
Okay.
I mean, the whole volume replication is just a desire to say which PVC, what do I want its state as, primary or secondary, and what's my volume replication class for the other.
Got it. Those lines were confusing.
Yeah, I'm sorry. Yeah, got it. So this is the replication management lines, the solid lines, the data and control plane for the storage system. They will be 2, but we've just represented it as 1.
So we talked about the data. The data from a PVC is volumes going from one to the other, but you didn't talk about how you're going to send the other Kubernetes config data from one side to the other.
Right.
Yeah, I missed it.
No, you didn't. So I said all the way up, I said we're not yet dealing with the application resources like pods, PVCs, config maps in this talk. But having said that, we are this whole solution. So let's go back. So copying this PV is bad, right? So what we probably really want to do is we really want something like a replication handle being reported as a transferable replication handle being reported back in the volume replication resource, which hence the user can take and recreate the volume replication resource on the secondary cluster instead of pointing to a PVC that would instead have a source of the replication handle. I know we're getting a little bit into the design. I don't intend to, but what I want is we definitely have to break the PV linkage here, and PVC, because we have any data source now, thanks to Ben, I think. We can actually create a PVC from any data source which points to a volume replication instead. So that way we can break the dynamic provisioning problem, as well as giving the user the ability to transfer the replication handle across these clusters. Now, getting back to your question, what we are looking at is a GitOps-like structure to transfer application resources like pods, PVCs, let's just say pods, PVCs, and such. The other alternate that we had earlier considered was queue backups of these resources. I don't know, I think different people may want to do this differently, but we are not tackling that particular problem. I think there are existing solutions for that, and I don't think we need to do that. That's my that's what we believe.
But there are sequencing concerns when you're trying to restore something, depending on exactly how the destination PVC needs to get created and when relative to everything else that should happen. So yeah, there are other solutions that do it, but you have to have an opinion about timing and sequencing.
Yes, definitely. So, like I said, so in this sequence, this is in this setup where we're actually transferring PVs. The sequencing is obviously strict. I mean, the PV is restored first, and then the PVC is restored or created based on the application resources so that it can bind to the PV. And later on, it can create, at this particular point, even if the volume replication is not created, the volumes are actually secondary on West. Until the volume replication resource comes in and changes its state to primary, that's not going to change. So technically, the storage driver would disallow mounts, maps, or usage of that volume. All the node stage requests should fail, even if a pod comes in out of order from the volume replication resource. And when the volume replication resource comes in, that's what trickles down to the storage layer to either force promote this to a primary or whatnot. So yes, there is a strict here.
So failing the node stage or the node publish would be a way of preventing like an early pod from causing havoc, but we would still need to have like a recommended way of doing it, because if you just create the pod first while the volume is still the secondary, the pod just keeps failing and failing and failing, and then eventually you do fail over. Like the exact retry loop of when the pod is going to try to come up again is going to be fairly random. And you might want it to come up quickly, and it might be planning on coming up 3 minutes from now because of the retry loop. You would want to have a way of saying, to minimize the downtime in a failover scenario, when exactly should you create that pod so that it can rapidly successfully come up in the minimum amount of time. That's the kind of feedback that I think people would want, or that's the kind of information people would want to have access to.
But Shyam, if I understand this proposal, I think maybe what you guys are saying is whatever Ben is saying here and the application logic, that's not in the scope of this proposal. You are assuming that a higher level layer will coordinate some of that, the sequencing, etc. But you are kind of abstract away the definition of volume replication. Is that kind of true, so that it can be agnostic and and it's like Kubernetes standard?
Yes, that is true. But to Ben's point, the PV copy model is very prescriptive on order, right? We cannot break this order, right? Whereas what we really want to do is, sorry, this is not moving. Oops. Okay. So, whereas what we really probably want to do is always create a PVC using volume replication as its data source, so that these ordering constraints are not there. So the moment the PVC is created, there is a populator, and the source is a volume replication resource. It does what the PVC is not going to be in bound state. It's going to be so that the pod cannot use it anyway, and sequencing works transparently, right?
So sorry to interrupt. I think we only have 5 minutes, and there is another issue that we need to get to. Can we continue with this?
Sure. Sorry, I didn't check the time.
Thanks, Shyam.
Okay.
Thank you, Shyam. This is very interesting. I think we can follow up offline, right? If the group is interested in this, we can certainly have another session, a shorter session, to discuss the remaining things.
Yeah, I'd like to echo that this design looks good so far. It's very close to what we've been designing for a similar proprietary implementation of this. So I have a lot of good feelings about it.
Okay, thank you.
Awesome, nice, and we will discuss more. Thank
Okay,
you.
yeah, so
Thank
let's
you.
see if we can, come back, talk about this in the next meeting. So,
It's Grant here. I think he created the issue.
I don't think it's a grant.
Anshu.
I added the issue in the doc, and I think Xing also replied to the issue, but I'm not exactly sure if that issue has been fixed yet or. You can open.
So yeah, I can open that. Grant, is Grant here today?
No, he's not here.
Yeah. So I guess that was my question. I was reading this one, right? So basically, this is a bug report saying that the create snapshot is being retrying without the backoff. But the error that I see in this logs, this one should not be there anymore if you test the latest code. So that's why I was asking.
We didn't get a chance to try out the latest code. Like, so the release was 4.2.1 since August, and there has been no release since then. So
okay, yeah, we have an RC release actually. If you want to give a try, there's a 5.0 RC1.
Okay. Let
me. I think Grant is still looking. I will ping him and see if he has got any update. Another thing I'm thinking, maybe Xiang, we can talk about this offline, is because for if it's dynamic provisioning, we actually call create snapshot multiple times to get the status of the snapshot. But then we ended up calling create snapshot multiple times. So maybe I'm wondering if CSI driver supports list snapshot with a snapshot ID, we can actually use that to get the particular snapshot status instead of calling create snapshot. I don't know if that would help. So Xiang, maybe we can talk about that. I'm thinking that might be something we could consider as well. Well, I'm sorry, Xiang. I was trying to say Xiangqian.
I was confused.
Okay.
Okay. Yeah. I'll take a quick look on that.
Yeah. So
these logs they pulled from the logs at Xiangqian at like via shared at above, or where did you get this log?
The log because it's here.
This one. So if you see right, what even Griffiths had mentioned, the calls were happening very frequently, and like the fact that I mentioned, right, the API was getting throttled in the cluster itself. So that logging is probably not accurate as per what.
Yeah, I think Grant says he thinks this probably still happening. I think he's still trying to figure out. I think he added some notes earlier, but I think he still have not got to the bottom of it. Sometimes
because we tried a fix around in the Azure CSI driver to at least prevent the throttling, because it was a very scary situation, because any failed snapshot and all, it was just bringing out the cluster in some sense, right? If you're throttling the vendor APIs. So I think we should like try to prioritize if it's not already fixed.
Yeah,
I haven't gone through the whole thread yet, but are there any replication steps?
You just try to create a snapshot which like does not have the right permissions, or like some missing permissions, some error scenarios. In few of those, we were able to replicate that. The retries were constantly happening. If you go and see the control plane logs, retry timestamps that also Griffiths mentioned at the top, they were very close to each other. It was not waiting, and there was no terminal state. So I had a cluster in which I had a failed snapshot. It kept retrying for a month.
Oh yeah, but so we will keep retrying, that is for sure, because that's actually to avoid leaking.
The exponential should increase, right?
Yeah. So the reason, the problem is why this does not wait, right? So we do have that logic there, but somehow it did not go there for some reason. So that's something that we need to figure out. So I will pin Grant and just see if he has any update on that. Yeah, we'll take a look.
Thank you. Thanks a lot.
Okay, thank you for reporting this. Xiangqian, do you have anything else? Looks like
no. We're all good. We're right at time. I'm gonna just stop recording.